In this video, we are going to be looking at operators with numbers or variables. This is a good question, and there was an issue I was recently debugging that involved a similar problem. And understand that both solutions are right, as we're going to see when we look at the examples, that we can use numbers directly or we can use variables. The trick with numbers is it tells us immediately what it is, but then we don't get to have reuse, as we'll see. Variables, we just have to make sure we remember what those variables are, especially if we're updating them or changing them. So let's go ahead and look at an example, and I'm going to just show you all that the output is always the same when doing this. So for instance, another thing as well I should highlight, we're also looking at the operators themselves. So we have this two variables, the v up and the v down, and they're both ints. One is 50 and one is 100. We're going to work with the v down first. And we see that we divide 100 by 2, and we see answer divisible 1. And then we see this should be answer divisible by 2, but it's not. But we're multiplying it times 0.5, so we can see this is the same operation. That's something to consider as well, because it is true that this, and in some it depends on the environment. These may not be necessarily the most readable ways to do that, right? Depending on the environment. It might be more intuitive for people to see multiply times 1/2. It also might be more intuitive for people to see divided by 2. One of the great things about as you see with the multiplication, when you do by 0.5, which of course is a half, it spits out a decimal on you. And I like that. If I'm trying to get it automatically to decimals, it automatically does that for me. Of course, and then we see the same thing with the effect of the v down divided by 2. As we see, we get that 50, the same, again, values. The difference is now we're using a variable. Now, if we were using this variable throughout, and we were in the middle of debugging, we would just need to remember what that variable was, right? So we just need to remember that this is 100. Again, it should be pretty straightforward, but when you're debugging, you might forget what it is depending on how much code is written, and then of course we multiply that times 0.5. And again, we can see these are the same answers. Keep in mind, it's just in one of these cases, even though this is an integer, notice how the answer comes out to be a decimal. Of course, that's one of the effects. And then we have the other example with v up. So this is, of course, our 50 value. And we see, again, the same type of situation. So in this case, what we're doing is we're increasing half the value. The example that we were looking at for those of you kind of wondering was, why is it that, or the effect of a 50% increase and a 50% decrease. This slide over here is a 50% decrease, as you can tell. And you'll notice that a 50% increase only ends up at 75, whereas a 50% decrease starting at 100 ends at 50. And so the student who is learning math was kind of wondering, why is it that those don't equal the same value? And it's because of the starting point, of course. But as we see, when we try to do this multiple answer, not try, but we actually complete this, we're adding 50 to, of course, 50 times 0.5. So this is the half of the value plus 5. Of course, that's 75. And we'll notice how this all comes out to be decimals, because notice how we're using decimals in each of these, right? So whether we're using, again, the variable or we're using the actual value, these all come out to be decimals. And that's because that's what we're using there. So just keep this in mind, that we could use the variables or we could use the numbers directly, or those are the options, I should say. But if we're using the variables, we are going to have to remember what the variables are if there's a lot of code. Likewise, if we use the numbers, we don't have the repetitiveness of the numbers. We have the repetitiveness of the numbers that we have the code for, is what I'm trying to say. And so that can be, it's not a bad thing. In a way, it may make it easier to troubleshoot depending on how things are done. Like for instance, let's say we're using a variable twice, but the variable is a number, let's say like 73.164, and then let's say that the next part of the code is way far down. It might be better in that case to use the number over the variable, but it might not, and it depends. Now, just to also remember, and of course I have this listed here, is order of operations, right? So keep in mind, if we are going to use variables and we're using a bunch of mathematical operations, which we see more in this slide than anything, for instance, right here, we do need to make sure that the operations order is correct, because otherwise that can also be, when you're trying to debug something. And I'm always think of designing and development from the perspective of debugging. That's where we're going to spend a lot of our time. We just want to make sure that it's intuitive. So one of the things that you can do, by the way, with order of operations is you can break it out. I didn't do that in this select statement, but you could have remember first, and then you could have order plus of, then you could have order plus of minus operations, and you could break it out and see what each of the values are when you're debugging. And so that's a helpful technique, and you can easily comment it in and out in case you need.